So continuing with the lesson on program with C++. Today we are looking at functions. We look at what a function is. We look at the declaration of a function and the definitions of a function. So when we say a function, what do we mean? A function in C++ are blocks of code designed to perform is a block of code that is designed to perform only a specific task. They are fundamental for organizing codes, promoting reusability, and making programs easier to manage. So they make it easy for you to reuse a part of a code, and then they make the programs easier to manage. So it makes it easier for someone else to come and understand what's going on. And also, so we have the types of functions. We have user-defined functions, and then we have the standard library functions. So the user-defined functions are the ones created by the programmer to perform specific tasks. So, for example, I can create a function on my own. So when I create a function, then that becomes a user-defined function. We have the standard library functions, which are predefined functions available in C++ libraries. For example, the std colon colon, cout, the std colon colon, sqrt, and all that stuff. So we have types. So continuing with the types, we have the virtual function. These virtual functions is based. These virtual functions, they are functions in base classes that can be overridden in derived classes, enabling polymorphism. So they are in the base class and can be overridden in the derived classes. So they enable polymorphism. Sorry. And then we have the inline functions. Functions where the compiler replaces the function called with the function's code, potentially improving performances for small functions. So why are functions important? So the benefits of functions are modularity, which means they break down complex programs into smaller, manageable units. And then reusability. Reusability is like you write the code once and use it multiple times. So when you write one code, you are able to reuse it several times. Then we have improved readability. So it makes the code easier to understand and maintain. Yeah. So how do we how do we how do we declare a function? So let's bring the skeleton of our C++ here. So how do we declare a function? So the syntax for declaring a function is you bring the return type, then you bring the function name, then you bring the parameters of the function inside the parentheses. So let's say, for example, we have a function. The function sum, since it says sum, it's obviously going to be numbers, and the best numbers is into, let's say, our data type integral. So if you're having a compiler. Okay, so our data type is integral. So we want to create a function called find sum. So the function to find the sum of something. So after the syntax is, we bring the return type. So right here we are just declaring a just writing down the basic syntax. So find sum, then we bring in in the find sum, then we bring the data types. Bring the data types. So this one will be first number. So first num. Then we bring the comma. Then we bring the again. After which we terminate this line. After which we terminate this line. So once terminate it, this is actually supposed to be done in the global. It be a global declaration and not a local scope. It's going to be in the global scope, not the local scope. So we'll now come down and bring our global scope, our local scope in here. I don't know what's wrong with our metric today, but we'll manage it like that. So after doing that, then we'll come and output our function here, and then would bring the values to represent the declared variables in the here. This is declared variables over here. We will then use values to represent it down here, as we done in here. And then after that, we'll run it and see what will happen. See, we're having an error here. So let's example of a function and let's break it down. So when we take, let's take a real function. This is just a function declaration. The syntax for the function type, the function name, and then you put the parameters. Then you bring the you put the parameters in the parentheses, and then you open your curly braces, and then you put the statement that the task is supposed to perform inside your curly braces. So let's explain what we mean by return type. Return type specifies the data type of the value the function. So when you use void, you say use void if the function doesn't return a value. So if the function is not supposed to return a value or give a void return type, but then we have parameters. First of all, after the data type, you have the function name. So the function name is an identifier that uniquely names the function. So after that, we have the function definition. We have the function parameter. Parameters are the inputted values passed onto the function declared with their types and names. So you declare as declared above, you now come and input the data passed with their you come and input the values passed to the function declared with their data types and names. Then we have the function body which contains the code that executes when the function is called. Then we have the return statement. This is value back, not the return type is not void. So over here, we'll write a sample function and we'll break it down to see how well the function works. So let's try this and see. A function is declared in the global scope. Function is declared in the this is an integral function. So we bring the return type, then we bring the data type, we bring the identifier of the function identifier or the function name. Then in the function name, we bring the parameters. So which parameters are we using? We're using an we are using another one. This is the second number. So after which you bring your curly braces. When you bring the curly braces, then within the curly braces, that's when you set what the code this put the body of the code. So you explain what you want this function to do when it's called. So this is what this function is going to do. Let's run this code and see what will happen. So earlier on, we did the declaration only. So now this is the declaration, this is the definition of the function. So what we are going to do is we will now declare the variables. Then we'll run this again and see what will happen. Okay, so we have no errors now. So it means our code has run successfully. But the reason why it hasn't outputted anything is because we haven't assigned any values to the first number and the second number. If we were to assign any values to first number and second number, then this code would have run successfully. So let's let's now make it, let's assign a and see what will happen. And let's run this code now and see how the code runs. Okay, okay. So currently our code is running without any errors or mistakes. This is so when we say functions. Functions is made up of arguments as well. So arguments are the actual passed function when it is called. So the values that you pass to a function when it is called are what are called the arguments. So the syntax for creating an argument is bring the function name, then you open a parenthesis, then you bring the argument, the first argument and the second values to represent the actual declared data types in the function itself. So let's say in our code we have first noun and second noun. So if we want to So we have what we call a default argument. This is the actual value assigned to the parameter during function definition or declaration. So the default value are the actual functions that are assigned to a function or assigning. This is at this point, at this place. That's the actual value assigned to it is called the default argument. So let's say we have something like this. So we have something like this. Let's say this is how a default argument looks. This is an example of what a different default argument looks like. So you return, you terminate this. So this is what a default argument looks like. We have an error here. So we have what you call the function calling. So to execute a function, you call it by its name, followed by parentheses and any required argument. So the syntax for calling a function is you bring your function in there, you bring the parentheses. In the parentheses, then the argument that the function is supposed to work with. We also have what you call function overloading. Function overloading, this is defining multiple functions with the same name but different defining multiple functions with the same name but different parameters. This is used in cases where there is function name but differences in parameters. Function overloading, a function in C++ can be overloaded in three ways. So we have use of overloading a function in C++. We have by having different numbers of parameters, or you can also do it by having parameters, or you can do it by having both different types of parameters. So you can do it by different numbers or different parameters or both combined. So let's say you want to overload a function using different different number of parameters. You want to use different number of parameters to overload a function, right? So let's see the name of our function is Okay, we're having some problem with our the yeah. So let's see what our the name of our function is. Now this is that we put in our argument. After which we open our curly braces to input. So we can overload the same add function by creating another add function. Yeah, overload it by creating another add function. So in this function, since we are doing the one that we have the different type of overload. So the overloading we are currently doing is the one that involves functions with different number of parameters. So you have the same function name but different number of parameters. That's the type of overload we are looking at now. So we bring the first one, then we bring the second parameter, then we bring the third parameter, then you terminate it. Oh sorry. So after this, then you bring this, then you bring. So then after this, you terminate it. So when we say functions with different number of parameters, when we say overloading by different number of parameters, this is what we mean. So it's the same function add here. This is the same function add here and the same function add here. But then the number of parameters differ. So that's what makes this a different this is the first type of overload. And then we have different types. Okay, so this one is different number of parameters. So the next one we are going to look at is different types of parameters. Different types of parameters. So for different type of parameters means the data types will be different. The parameter data types will be different, but the function name will still be the same. So let's say we have this one to be an integral data type. So since the first one is an integral data type and we are doing different types of parameters, the second one must be a different data type altogether. So let's say the second one will be a double data type. So here we come down, then we open our brackets, and then we put in what. So So this is the second type of function overload, which is the different types of parameters. So this the first parameter is an integral, but the second parameter is a double. So the functions are the same, but then the functions, the roles that the functions play are different because the first one is an integral and the second one is a double. Then we have overloading by both the different numbers and different numbers and different types of parameters. So you combine both this one and the first one that we did previously to get this this third type of overload. So in this one, you can have a mix of different. So in this one, you can mix different data types in the first parameter and then mix different in the second function, be an overload. So let's say our first function is, so in int add, we have the first value to be a double, then the second value to be an integer. So over here, to so this is the first function that was created. So now we'll come down and create another function. In this compared to the first one. So over here, what we'll do, return the terminate it. So here we have we have integer data, we have the integer function add, and the second one is a double function add. But that's not just the difference. The first one has a mix of the integer and the double data type, and then the second one has a mixture of the integer and double data type. But then the second one has more, it has more, but then the second one has more parameters compared to the first one, and that's what makes it one, which is overloading by different number of parameters. Then the second, which is overloading by different types of parameters to form a new type of overload. So this is all we'll do on overloading today. We'll do on functions. So functions basically is when a user creates a user defined area in the code that he or she may be able to call specific task which the code itself has not defined yet. Thank you for staying with me.